All right, so let's look at a different example now. Here I have ln of 2x minus ln of x squared plus 1 equals ln of 1. And we want to know what values of x makes this statement true. Well, we're going to go ahead and write this as an ln on each side, and we're just going to go from there. We're going to use our one-to-one property once we get it down to a single logarithm, set up an algebra equation, solve the algebra equation, and then check for extraneous solutions. So here I have minus. So minus with our log rules means it's division. This is my numerator, this is my denominator. So I'm going to have ln of 2x over x squared plus 1 equals ln of 1. Okay, at this point there's a couple of different ways you could do this. You can recognize that ln of 1 is 0 and just simply say this whole thing has to equal 0. Means that this whole thing here has to equal 1. But we can use our one-to-one property. We know that whatever's on the inside here has to match the inside here. So I simply get 2x over x squared plus 1 equals 1. And then we're going to solve from there. I'm going to multiply both sides by x squared plus 1. So now I have 2x equals x squared plus 1 because I just multiplied it on the other side. I'm going to go ahead and subtract over my 2x. I've got 0 equals x squared minus 2x plus 1. Lo and behold, this is a perfect square trinomial. So this factors to x minus 1 quantity squared. From here I can just simply solve it, take the square root of both sides, add 1, and I'm going to get x equals 1. Alright, so now that I have my solution as x equals 1, what I actually need to do is I need to plug it in and make sure everything on the inside of the logarithm is greater than 0. So I'm going to put this 1 here. 2 times 1 is 2, greater than 0. I put my 1 here. 1 squared is 1 plus 1 gives me 2. That's perfectly fine. And then 1, I don't have to plug it in. So this is a solution. I have no extraneous solutions. Now you may also think, hey, wait, I've got a denominator here. There's some numbers I got to throw out, some excluded numbers. But I actually argue you don't, because there is no real number you can put in here in which you would ever get this to 0. Because if we try to do that, we get x squared plus 1 equals 0. We're going to get x squared minus equals negative 1, which is going to give me x equals plus or minus I. So the only thing that would make your denominator 0 is a complex number. In fact, it would just be I itself. So there's actually no domain restrictions on here. There's no extraneous solutions. Not bad. So you notice the ln versus the last one of the videos we did where we had log base 2, that doesn't even come into play when we're solving these. If we get them down to a single exact same logarithm with the exact same base, we just take the inside, set them equal to each other. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.